In this video, we're working additional examples of writing the equations of lines, and we'll see different aspects in each example. But the common theme in all four examples is that you're given at least 1 point. Right? We need a point and a slope in order to write the equation of a line. You're always going to be given a point. You have to know the point in order to write the equation of a line. And you also need the slope. Now, you may be given the slope, you may not be given the slope, but you've got to have enough information to be able to find what that slope is if you're not just handed the slope. For example, let's take a look at number 1. Find the equation of the line passing through -1, -2, and 3, -4. Now, we're given a point. We're actually given 2 points, but we don't know what the slope is. Right? But the question that we're asking ourselves is, do we have enough information to find the slope of this line? And sure we do. We've got 2 points. Right? So I can find the slope by using the slope formula. Right? That's the first thing that you want to ask yourself is, do I have a point? Do I have a slope? If you don't have a slope, you will be able to find it. All right, so let's find the slope of this, of the line passing through these 2 points. So we'll subtract the y values, -4 minus a -2. And then subtract the x values, 3 minus a -1. Okay, again, being careful with subtracting negatives. -4 minus a -2 is equivalent to -4 plus 2, which is a -2. And 3 minus a -1 is equivalent to 3 plus 1, that's 4. Okay, and that simplifies to a -1/2. So we have found what the slope is, which is -1/2. Now we can use the point slope form to find the equation of the line. We only need one of these points. Doesn't matter which one that we choose. I'll just choose the first one, -1, -2. You could just as easily chosen the 3, -4. And you may want to try this using the 3, -4, just to make sure that we do get the same equation and that in fact it doesn't matter which point that we use. All right, so the point slope form is y minus y1 equals m times x minus x1. Right, I'm calling -1 the x1, the -2 the y1, and of course the m is the -1/2. So y minus a -2 equals -1/2 times x minus a -1/2. Okay, and so, and if the directions do not indicate what form it wants the answer in, you can assume it's in slope-intercept form, right? We said that's the more common form that we're going to write our answer in. So if it doesn't specify in the directions, write your answer in slope-intercept form. All right, so I really want to be careful with my negatives, right? These minus negatives always mess me up. So I'm going to change those to plus as the first step that I make. So then when I distribute the -1/2, I've got, let's see, what have I done here? Y minus a -2 equals -1/2 times x minus, I put a 1/2 here. What should that be? That should be, glad you caught me on that one. That should have been a -1. Okay, my eyes just went to this -1/2. All right, so -1/2 times x minus a -1, change those to plus, and then distribute the -1/2. That looks much better. All right, distribute the -1/2. So that's a -1/2 x, and -1/2 times 1 is -1/2. All right, so now if I'm writing this in slope-intercept form, well, first of all, if I wanted to write this in general form, right, a good next step is to get rid of the fractions by multiplying by 2. And you can do this whether you're putting it in general form or slope-intercept form, because fractions are always messy. All right, so let's do this. Let's multiply everything by the denominator, which is 2. All right, so by multiplying by the denominator, I get rid of the fractions. All right, so 2 times y is 2y, 2 times 2 is 4, 2 times negative 1/2 x is negative 1x, 2 times negative 1/2 is negative 1, and then I can write this in slope-intercept form by solving for y. I'm going to solve for y by subtracting 4 from both sides. So subtract 4 from both sides, which will result in 2y equals negative x minus 5. And then our last step, we want to get y by itself, right? We're solving for y, so we can divide both sides by 2. Right? We're dividing everything by 2. So our final answer in slope-intercept form, negative x over 2, I'm going to write that as a negative 1/2 x. And that's a minus 5/2. So we have y equal negative 1/2 x minus 5/2. The y-intercept is negative 5/2. The slope is negative 1/2. All right, that is the equation of that line passing through our 2 given points. So if we're given 2 points, we need to first find the slope. All right, now looking at example 2, right, we're given different information. Find the equation of the line passing through 0, negative 1 with slope negative 2. So this is the same setup as the first example that we saw in the previous video, to where we're given a point and we're given a slope. Right? So we can go directly to the point slope form, plug that into the point slope form, solve for y to get our answer in slope intercept form. Okay, but this is a special point. Okay, why is it a special point? Well, look at the x value. Right? The x value is 0. When the x value is 0, think about the graph. Okay, when x is 0, that means the graph is crossing the y-axis, right? If you're on the y-axis, that means you're not moving to the left or to the right of the origin. That means you're on the y-axis. That is the y-intercept. So when when x is equal to 0, right, this guy right here is the y-intercept. Right, that's the b in the slope-intercept form. So if you're given just a generic point, you can use the point-slope form. But if that point is a y-intercept, then this is actually a much easier example, because you can use the slope-intercept form directly, because I know that the b is negative 1. I'm given what that y-intercept is. So there's really no work I have to do. It's just a matter of recognizing that this point is the y-intercept because x is equal to 0. So what's my slope? The slope is given to me, negative 2. And what's the b? That's the y value of the y-intercept when x equals 0. So the y-intercept is negative 1, so minus 1. And that's it. That's the equation of the line passing through 0, negative 1 in slope negative 2. No work that I needed to do there. I could have done work by going through the point slope form, right? But usually take the easiest route. Okay, the easiest route in this case is the slope intercept form. All right. What about example 3? Find the equation of the line passing through negative 1, 3 and parallel to the line 2x plus 6y minus 12 equals 0. So in this case, we're asking ourselves, are we given a point? Are we given a slope? Yes, we're given a point, negative 1, 3. Are we given a slope? No, we're not given the slope, but do we have enough information to find the slope? Yes. Yes, we do have enough information to find the slope. using this information that we know that this line is parallel to 2x plus 6y minus 12 equals 0. And we know that two lines are parallel implies that the slopes are equal. So if I can find the slope of this line, then I know the slope of the line that I'm trying to find. All right, so how do I find the slope of this equation? Now, what form is this equation is, right? I said equal to 0. That's called the general form. Okay, so this is in general form. In order to find the slope, we want to convert this to slope-intercept form, because then the slope is the number in front of x. To do that, we can solve for y, right? So we're going to move every term besides the y term to the right-hand side. So that would mean we would subtract 2x from both sides and add 12 to both sides. All right, so that would be, so we're subtracting the 2x and we're adding the 12. All right, so we have 6y equals negative 2x plus 12. And then solve for the y to get it in slope-intercept form. All right, so we're dividing everything by the 6. Okay, and by doing that, we have y equals negative 2x divided by 6. That's a negative 1/3 x, and 12 over 6 is 2. I don't really care about that 2 because what am I after? The only thing that I'm after here is the slope, right? Because this was the equation that was given, and I was told that this equation is parallel to the line that I'm looking for. And the line that I'm looking for will have the same slope as this line. So the slope of this line is the number in front of x since I've written this equation in slope-intercept form. All right, so the slope is negative 1/3. So I can use that along with my point negative 1/3. So now this example becomes the same as the previous example in the other video that we had, using the point slope form. All right, I can call x1 to be negative 1 and y1 to be 3. So y minus 3 equals negative 1/3 times x minus a negative 1. I'm going to change that minus and negative to a plus. Go ahead and do that. All right, so we have y minus 3 equals, distribute the negative 1/3. And maybe you even want to multiply everything by 3 before you even distribute that to get rid of the fraction. Whether you do it in that previous step or the step here, right, I'd recommend getting rid of the fraction. Even if you're putting that in slope-intercept form, it just makes it easier to work through without the fractions. All right, multiply 3 by everything. So 3 times y, 3 times negative 3 is negative 9. 3 times negative 1/3 x is negative 1x. And 3 times negative 1/3 is a negative 1. So now the only thing that you have remaining, again, if the directions do not specify, put that in slope-intercept form by solving for y. So we'll add 9 to both sides. So 1 plus 9 is 8, and then we'll divide both sides by 3. All right, so when we divide everything by 3, we get y equal negative 1/3 x plus 8/3. All right, slope-intercept being 8/3, and slope being negative 1/3. All right, and then in our last example, example 4, find the equation of the line passing through the point 1, negative 2, and perpendicular to the line passing through negative 2, comma, negative 1, and 4, comma, 3. All right, so again, we ask ourselves the same question. Do I have a point? Do I have a slope? Yes, I'm given the point 1, comma, negative 2. Am I given the slope? No, I'm not given the slope. So do I have enough information to find the slope? Hopefully, yes. All right, and this is the information that I can use to find what the slope is of the line I'm trying to find. I'm given that this line is perpendicular to the line passing through -2, -1, and 4, 3. And since I know that perpendicular lines have negative reciprocals for the slopes, if I can find the slope of the perpendicular line, then I can take the negative reciprocal to find the slope of the line that I'm looking for. Okay, so let's do that. So let's find the slope of this perpendicular line, the line that's perpendicular to the line that we're trying to find. We're not given the equation of the line, but we are given 2 points of that perpendicular line. So let's find what that slope is. We'll subtract the 2 y values, 3 minus -1, and divide by the difference, the x values, 4 minus -2. All right, so 3 plus 1 is 4. 4 plus 2 is 6. And that'll reduce down to 2/3. All right, so the line that we're looking for is perpendicular to this line. So we need to take the opposite reciprocal, or the negative reciprocal. So we'll flip that fraction to make it 3/2 and change the sign, make that a -3/2. -3/2 is the slope of the line that we're trying to find. So now we'll take the 1 -2 and the -3/2, and we will plug that into the point slope formula. Everything becomes the same once we find the slope. It's all the same procedure as what we've seen in the previous examples. So y minus y1, which is -2, equals m, which is -3/2, times x minus x1, which is 1. Okay. And this is what I was saying in the previous example, right? At this step, you could just go ahead and divide everything by 2, which I'll do that here to show you what that looks like, just to get rid of this fraction, right? So the denominator is 2, so multiplying everything by 2. Maybe I should say multiply the left-hand side by 2 and multiply the right-hand side by 2. All right, that'll get you 2y plus 4 on the left-hand side. And when I multiply the right-hand side by 2, right, when I multiply the right-hand side by 2, I'm doing that so I can cancel that denominator out with a 2. Right? So then I've got just a -3 times x minus 1. Right? And I'm not, don't make the mistake of multiplying by the terms on the inside by 2. Right, because that -3/2 times x minus 1 is all one unit. That's all one term. So when you multiply that whole thing by 2, that's going to cancel the denominator out. All right, so now we've gotten rid of the fractions, and then we can distribute that integer, that -3, giving us 2y plus 4 equals -3 times x, -3x, and -3 times -1. It's a +3. See, isn't that much nicer without fractions? So now in slope-intercept form, subtract 4 from both sides. I like showing that step just to help you visualize it. You don't have to show those steps, certainly. Anything in red, you don't need to show those steps in your work. But show those steps as you need to. You know, don't try to skip steps and sacrifice correctness. You know, show as many steps as you need to in order to get the correct answer. All right, so you subtract 4 from both sides, and then finally divide both sides by 2. All right, so that's a y equal, that's a -3/2x minus 1/2. Right, y equal -3/2 x minus 1/2 would be the equation in slope-intercept form of the line satisfying those conditions.